Dear students, in this video on ray optics, we will study simple and compound microscope with numerical problem. So let us begin with the first one, simple microscope, which is a convex lens, and we will take a special case when the image is formed at the least distance of distinct vision. So let me tell you what it is. For a normal human eye, an object placed at 20 centimeter can be seen clearly, and if you bring the object closer, then you cannot see it clearly. So this 25 centimeter is called least distance of distinct vision, and we represent it by capital D. So that we have to remember. Let's see, it is a convex lens and the object is placed between the lens and the focus. So you know this situation. In this situation, see, you will take one ray parallel to principal axis, and by definition, after refraction, it will pass through the focus, another ray through optic center, and I can take another ray through this optic center. And you know that rays passing through optic center do not deviate, and in this direction the rays are diverging, वो आगे नहीं मिल सकती, तो उनको आप पीछे बढ़ाएंगे. Produce the rays backwards to obtain a virtual and enlarged image. You see that. So you are familiar with this kind of image formation. If your eye is placed here, आप अगर यहाँ से देखेंगे तो आपको लगता है कि रेज यहाँ से आ रही हैं, but actually यहाँ पर कुछ भी नहीं है. So this image A dash B dash is virtual image, virtual, erect and enlarged. और हमको क्लियर दिखने के लिए इसकी डिस्टेंस 25 सेंटीमीटर होनी चाहिए. So this distance must be 25 centimeter or least distance of distinct vision. So let me complete it first. And here you see the object distance taken as x, image distance is d, and we need to make some constructions here to define magnification. So what we do is, I made one construction at this point only, at distance d only here, at the place of the image, I have taken a height a double dash b dash which is equal to the size of the object. And now what we do is find the angle or mark the angle subtended by this height which is equal to size of object at the optic center C or at the lens. And your eye is placed very close to the lens, so this angle can be treated as the angle subtended at the eye. And now mark another angle. See, the final image is this one, and this is the angle subtended at the lens by the final image, right? So ये एंगल अल्फ़ा बीटा है, वो आइज़ के बहुत क्लोज है, तो हम ये मान सकते हैं कि अल्फ़ा और बीटा आपकी ऑब्जर्वर की आई के ऊपर ही बन रहे हैं, राइट? एंड ये हाइट ए डैश बी डैश विच इज़ इमेज एंड ए डबल डैश बी डैश विच इज़ इक्वल टू ऑब्जेक्ट, ये दोनों एंगल्स अल्फ़ा और बीटा आई पर सबटेंड कर रही हैं, तो इनकी हाइट का रेशो इन एंगल्स के रेशो के बराबर होना चाहिए. सो इट मीन्स मैग्निफिकेशन कैन बी डिफाइंड एज बीटा अपॉन अल्फ़ा. So now see, it's working. Object AB is placed between the lens and its focus so that its virtual image is formed at the least distance of distinct vision D, which is this one, 25 centimeter, and relation for its magnification is beta upon alpha, this angle beta upon alpha. And now before I move to next slide, let us discuss few things here. You see, this beta and alpha, these angles are very small angles, so they can be taken as 10 alpha and 10 beta. I can write it as 10 beta upon 10 alpha, right? See what happens then, 10 alpha. Now from this triangle A dash, B dash, C, A dash, 10 beta is equal to A dash, B dash upon this distance. And if you look at this smaller triangle, A double dash, B dash, A dash, then 10 alpha will be equal to A double dash, B dash upon this distance CB dash, which is D. So when you take the ratio, see this distance is same, CB dash, so it will be cancelled out and you will get A dash, B dash, size of image upon this size, and this size is equal to size of object. So that means this 10 beta will be equal to size of image upon size of object, which is magnification. So एक triangle हम ये consider करेंगे, और we can consider one more triangle. I can consider this triangle A, B, C. So here you can see that 10 beta is also equal to AB upon CB. Look at this smaller triangle. 10 beta is AB upon CB, and 10 alpha is same, A double dash, B dash upon CB dash. So we will find out the value of magnification using two different sets of triangles, and then we'll get some relation for it. So our interest is to find out that relation. So definition of magnification, it is the ratio of angle subtended by the eye, angle subtended by the image at the eye to the angle subtended by the object at eye when both are placed at the least distance of distinct vision. So magnification M is equal to beta upon alpha, and now as I told you, we are going to take these triangles. So beta can be written as 10 beta, alpha as 10 alpha. 10 beta is image A dash B dash upon CB dash. 10 alpha is A double dash B dash CB dash. CB dash cancelled. So you are left with numerators A dash B dash, which is image, और A double dash B dash ये आपने construction किया है, and this is equal to AB. So in place of this I can write AB, which is object, and you know that size of image upon size of object is magnification. So now the same magnification can be found out, or the values of 10 beta and 10 alpha can be found out using different triangles. So I have just shown you from the smaller triangle 10 beta is AB upon CB and 10 alpha is same as this one. Now in place of A double dash B dash I have written AB, and this CB dash is already there. So AB and AB cancelled. This CB dash goes up and CB comes down, and from the diagram CB dash is equal to minus D and CB is equal to minus X using the sign convention. So if you look at this one once again, see here, CB is minus X, direction of incident ray is this, and we are measuring this in opposite direction, and CB dash is equal to minus D because it is in opposite direction of that of the incident ray. So now let us get back to this one once again. So the relation for magnification is D upon X. Now we want to find out this magnification in terms of the focal length of the lens or microscope. So we are going to use the lens formula now. And if I am using lens formula, then what? The image is formed at -d and the object is placed at -x. So put the value of v and u in this equation, and when you do so, see what you get. 1 upon f is equal to 1 upon -d minus 1 upon u is equal to 1 upon -x. And I have to find out d upon x. So multiply both sides by d. So the left side becomes d upon f, right side this becomes d upon -d minus this becomes d upon -x, and when you do it, this minus and this minus become plus, and then you get d upon x, and d upon d cancelled, you get -1, so d upon x minus 1. So now you have got this d upon f is equal to d upon x minus 1, and I want d upon x, so keep d upon x on one side and take this minus to the other side. So you get d upon x is equal to 1 plus d upon f. D upon x, see, d upon x is equal to 1 plus d upon f, and this d upon x is the magnification. So magnification by a simple microscope is given as 1 plus d upon f when the final image is formed at the least distance of distinct vision. So this is a very important relation and very important derivation also. So now let us move to the next situation, simple microscope. When the image is formed at the infinity, and let me discuss this first, see. When the image is formed at infinity, it is also called normal vision. Why normal vision? Because when you are watching something at infinity, your eye is relaxed, your eye is in relaxed state. So it is called normal vision. So if we use the word relaxed eye, we are talking about normal vision only. So the final image must be formed at infinity. So let's see what we do for it now. So you have an object, same diagram, see. Now to make the image at infinity, you know the condition that the object must be placed at the focus of the lens. So now the object AB is placed at the focus of the lens, and so this ray, which is coming parallel to principal axis, passes through the focus, and this through the optic center. They become parallel. So if you watch from here, these rays are parallel and they appear to be coming from infinity. So we can imagine that the image is formed at infinity, right? That means it is normal vision. So look at it. The rays are coming from infinity. You're watching. This becomes a normal vision. Now, the object distance is f, and look at it. Our definition is not changing. So look at it here. See, the object is AB, and for magnification, I have to take a height equal to size of object at the least distance of distinct vision. इससे पास हमारी आँख को कुछ भी नहीं दिखता है. And final image is at infinity, right? So look at it. The angle subtended by the object size at D is alpha, और image तो infinity पर है, तो infinity वाला angle beta. Look at it here. See, my image is at infinity. So if I take my image size here, let it be. So this image is subtending angle beta at the eye. Your eye is here. और ये ऑब्जेक्ट यहाँ रखा हुआ है, पर इसको भी हम यहीं पे रखेंगे और ये वाला एंगल अल्फ़ा, अब नाउ बीटा एंड अल्फ़ा विल बी कंपेयर्ड. So m is equal to, or magnification is beta upon alpha. So here, now it's very simple to understand. So magnification is beta upon alpha, that is equal to 10 beta upon 10 alpha, because angles are small, and 10 beta, from here 10 beta is AB upon CB. If you look at this triangle, 10 beta is AB upon CB, and 10 alpha is A dash B dash upon CB dash. And from here you can see that A dash B dash is equal to AB by construction. So these are cancelled out. CB dash goes up, CB comes down, and this CB dash is equal to minus D, and CB is minus F. So this is equal to D upon F. Look at it. Say this CB is minus F, CB dash is minus D, and this is equal to D upon F. So magnification for normal vision is D upon F. And see, so for a simple microscope, the magnification for normal vision is D upon F. So clearly, magnification for least distance of distinct vision is larger. And now let us talk about compound microscope. See, magnification by simple microscope is not much, and if you want more magnification, then we use combination of two convex lenses, and both of small focal length or large power. So one is called objective. We are considering the first case when image is formed at the least distance of distinct vision, and the lens which is facing the object is called objective, and the lens through which you watch is called eyepiece. So let us have a look. This lens, this is object AB, and this is objective lens, and this objective lens is facing the object, that is why it is called objective lens. It has small aperture. Aperture is the diameter of the lens, and it has large focal length, right? And the object is placed just beyond the focus of the objective. So objective lens will make a real enlarged image as A dash B dash, as you can see, and this image will act as object for this eye lens or eyepiece. Now what happens? We want to make final image at least distance of distinct vision. So you can adjust this lens in such a way that the final image is formed at the least distance of distinct vision, and you can watch it from here. So let's see what happens now. Look at it. Okay, see. So objective is making real image A dash B dash, and to make real image, the object is placed just beyond the focus of objective lens. This real image, ये जो real image बनी है objective से, ये real image eye piece के लिए object हो जाएगी, और using the same method, यहाँ देखो, take ray passing through optic center will go straight, और ये वाली rays जब इधर से जाएंगी, ये सारी की सारी rays ऑब्जर्वर की आंख में जा रहे हैं, और ऑब्जर्वर को ये आगे तो मिल नहीं सकती, तो ऑब्जर्वर को लगेगा कि ये रेज पीछे से आ रही हैं. सो फाइनल इमेज इज फॉर्म्ड एट A dash B dash, और ये डिस्टेंस होनी चाहिए इक्वल टू द लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन, तभी आप इसको क्लियरली देख पाएंगे. So let us another one more point to note. Now to make virtual image by this eyepiece, ये हमारी real image जो है वो eyepiece और इसके focus के बीच में होनी चाहिए. अगर ये यहाँ पर होगी तो आप virtual image इस side में नहीं बना सकते. ठीक है? So let's see. Let us mark all the distances here. Now, since we have to take the magnification, let us mark all the distances, then we discuss it. Okay, here. Now, what we do is we draw a length of size BA here. Look at it. And the final image and object. Look at it. The final image A double dash B double dash and an object size equal to this object are placed at one place at distance D from your eye. इनको मैग्निफिकेशन के लिए हमें इमेज साइज और ऑब्जेक्ट साइज को कंपेयर करना है. और कब कंपेयर कर सकते हैं? जब दोनों ही एक ही जगह पर हों. और वो जगह क्या होनी चाहिए? लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन. तो उसके लिए आप एक कंस्ट्रक्शन करेंगे इक्वल टू द साइज ऑफ द ऑब्जेक्ट, राइट? एंड नाउ यू विल कंपेयर द एंगल सबटेंडेड at the eye. So this is your, now the object size A double dash B dash is subtending, this object size A triple dash B double dash is subtending angle alpha at eye at this lens, right? And the final image is subtending angle beta at this eye. So we have to find out this angle subtended by final image at eye upon angle subtended by object size at eye, beta upon alpha. So even though the image looks little complicated, but it is not that difficult. See here, this is the final image distance, this is the focus, of this eyepiece, and remaining distances will look for them again and again. You see here. Now what is this objective? Objective is a converging lens placed near the object, and eyepiece is a converging lens through which the final image is observed, and they both have very short focal length, and the focal length of eyepiece is slightly greater than the focal length of objective. That means this FE is slightly larger than FO, and both are small. Okay, so now let us come to its magnification. Working. First working. Okay, I have already discussed the working, but this working is asked in examination also, so let's do it. The object AB is placed just beyond focus of objective lens. Real inverted image A dash B dash is formed by the objective. This image A dash B dash acts as object for the eyepiece. The eyepiece is adjusted to obtain virtual image A double dash B double dash at the least distance of distinct vision. So that's how we can explain the working of this compound microscope, and it's important, it is asked in examination also. And let us define its angular magnification or magnifying power. So magnifying power of a compound microscope is defined as the ratio of the angle beta subtended by final image at the eye to the angle alpha subtended by the object seen directly when both are placed at the least distance of distinct vision. Both are placed at the least distance of distinct vision. So magnification is beta upon alpha. I have already explained this to you and we are going to find out relation for it now. So here, see, beta upon alpha can be written as 10 beta upon 10 alpha, and the values of 10 beta and 10 alpha from the diagram are, this 10 beta is angle subtended by final image. So A double dash B double dash upon C2 B dash, and 10 alpha is A triple dash B double dash, ये जो construction किया था आपने, upon C2 B dash, right? Now these distances are same, cancelled out. We get A double dash B double dash upon AB. See, by construction, this A triple dash B double dash is equal to AB. So what we are getting now is, this is the final image, this is the object. पर इसमें बीच वाली इमेज नहीं आई है, इसको हम बीच वाली इमेज को भी लेकर आएंगे. सो m इज इक्वल टू बीटा अपॉन अल्फा और 10 बीटा अपॉन 10 अल्फा. अब इसमें मुझे बीच वाली इमेज लानी है. सो व्हाट आई डू इज a डबल डैश b डबल डैश अपॉन a डैश b डैश इनटू a डैश b डैश अपॉन ab. लुक एट इट. यहाँ पर जो इंटरमीडिएट इमेज थी हमारी वो भी हमने ला दिया है. सो दिस इज साइज ऑफ इमेज अपॉन साइज ऑफ ऑब्जेक्ट फॉर आई पीस. ये आई पीस के लिए है, मैग्निफिकेशन ऑफ आई पीस. एंड दिस इज साइज ऑफ इमेज अपॉन साइज ऑफ ऑब्जेक्ट, ये ऑब्जेक्टिव लेंस के लिए है. सो दिस इज मैग्निफिकेशन ऑफ ऑब्जेक्टिव लेंस. एंड if you look at the magnification of objective lens, so for objective lens magnification is V upon U. You are familiar with this relation. And for eyepiece we have just done this relation. Eyepiece is like a simple microscope and image is formed at least distance of distinct vision. So magnification for eyepiece is 1 plus D upon FE. eyepiece के लिए ये सिंपल माइक्रोस्कोप जैसा है कि यहाँ पर आपने इमेज रखी थी A डैश B डैश, और इसकी फाइनल इमेज हमने बनाई थी एट द लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन. तो बिल्कुल हम यहाँ पर माइक्रोस्कोप का फॉर्मूला लगा सकते हैं डायरेक्टली एंड पुट द वैल्यूज इन दिस रिलेशन एंड देन वी गेट मैग्निफिकेशन of a compound microscope is equal to MO की वैल्यू V upon U into 1 plus D upon FE. And if we make some approximation, you see, the object is placed very close to the focus of the objective, just beyond it. So this U, object distance for objective, is nearly equal to its focal length. And the image is formed very close to the eyepiece. So the V is distance between the objective and the eyepiece. Like it is nearly equal to the tube length. And if I do so, the relation for magnification becomes L, V is equal to L upon FO into 1 plus D upon FE. Now, this relation is approximate relation. ये relation सही relation नहीं है, ये है exact relation, सही relation, और ये जो है approximate relation है. Okay, and for normal vision. Now, if you are going to take normal vision, then you know that magnification of eyepiece for normal vision will be D upon FE. So in place of ME, I can put this one. So in place of this, I can write this. So in normal vision, the magnification of this compound microscope is L upon FO into D upon FE. But we prefer to use a compound microscope in least distance of distinct vision. And I want to show you the previous slide once again. Okay, this one here. See, this object is placed very close to the focus. So this object distance is taken as nearly equal to FO, and this image, the first image formed by objective, is very close to eyepiece. So this image distance VO is nearly equal to the total distance between the objective and the lens. It is also called tube length. So this VO is nearly equal to L and VUO is nearly equal to FO. So that is the approximation. So I hope you understand it now. And now let us move to a problem here. This is your NCERT problem, and very good problem, and also board problem. Look at it. A compound microscope consists of an objective lens of focal length 2.0 centimeter and an eyepiece of focal length 6.25 centimeter separated by a distance of 15 centimeter. How far from the objective should an object be placed in order to obtain the final image at the least distance of distinct vision 25 centimeter and at infinity, and what is the magnifying power of microscope in each case? So first, write whatever is given to you. So according to this question, FO is given to you, that is focal length of objective lens, and FE is given to you, focal length of eyepiece, and the separation between them, that is tube length L, is given to be 15 centimeter, and you have to find out UO. See, how far from the objective should an object be placed in order to obtain the final image? That means आपको ऑब्जेक्ट डिस्टेंस निकालनी है ऑब्जेक्टिव लेंस से. Okay, so for eyepiece, now if you look at it here, I have drawn this diagram for you. See, this is your objective lens, this is object distance, and it makes real image here. This real image is object for this eyepiece, and final image is formed here. So object distance for eyepiece is UE, image distance for eyepiece is VE, which is equal to D, and the total distance is V. So for eyepiece, position of image is minus 25 centimeter. See, this VE is equal to minus 25 centimeter at the least distance of distinct vision, and I can calculate UE. So using lens formula, 1 upon FE is equal to 1 upon VE minus 1 upon UE, and take UE 1 upon UE to the left hand side and bring other things to the right. So 1 upon VE will be 1 upon minus 25 minus, this goes to right side, so minus 1 upon 6.25. Simplify it, you get minus 1 upon 5. Take the reciprocal. This UE is minus 5 centimeter. So we have found out that this distance is 5 centimeter, right, from here till here. Now the total distance is 15. 5 centimeter ये चला गया, तो VO कितना बचा? 10 centimeter. And what is VO? It is image distance for objective. So now we are getting few things for this objective lens. So now the same diagram once again. So image distance for objective is 15 minus 5, 10 centimeter. So this is 5 centimeter. So this is 10 centimeter, right? And we can find out UO then. So using lens formula, 1 upon FO is equal to 1 upon VO minus 1 upon UO. इस 1 upon UO को left में ले जाइए, and on the right side you will get 1 upon 10. See, VO is equal to 10 minus 1 upon 2. Little more here. Yeah. So VO is equal to 10. So in place of VO, I have put 10, or in place of F, it is 2. Focal length of objective is 2. Simplify it, you get minus 4 upon 10. Take the reciprocal and simplify, and then you get this distance. Object distance as minus 2.5 centimeter. This is what we wanted, one part. And then we have to find out the magnifying power. Now, the relation for magnifying power when the image is formed at the least distance of distinct vision is this one, that is V upon U. This V upon U are for objective lens and 1 plus D upon FE. So for objective lens, the image distance is 10 V, object distance is 2.5 U into 1 plus D, the value of D is 25 and FE is 6.25. Simplify it and the magnifying power comes out to be 20. So for the least distance of distinct vision, the magnifying power is 20 and the object distance is 2.5 centimeter. And now we are going to find out the same thing for normal vision. Now see, for normal vision, the image must be formed at focus. That's very clear. That is a condition. For normal vision, the final image should be formed at infinity. That means this point must be the focus. The image formed by objective must be at the focus of the eyepiece so that the image formed by it is at infinity, right? So that means this distance is equal to, that means this distance must be equal to FE, focal length of the eyepiece, which is given to be 6.25 centimeter. तो बचा हुआ जो क्या होगा 15 minus 6.25. So let's see. So for normal vision, the image formed by the objective must be at FE. So the image distance for objective, this VO is equal to 15 minus 6.25. This is 6.25 and this is, when you subtract it, you get 8.75. 8.75. So this is image distance for objective, and again using the same relation, the lens formula, 1 upon FO is equal to 1 upon VO minus 1 upon UO. Change the side, simplify, you get minus 27 upon 70. Take the reciprocal, simplify, UO comes out to be minus 2.59. That is nearly equal to minus 2.6 centimeter. And for magnification, since it is normal vision, so magnification is magnification of objective MO into magnification of eyepiece in normal adjustment D upon FE. So put the value of VO, which is 8.75. We have just found out, you see. 8.75 centimeter upon UO, this much, into D is 25, FE is 6.25. So putting all the values and simplifying, the magnification comes out to be 13.5. That means image 13.5 times bada banega. And one more important thing to note here is, you see, here in least distance of distinct vision, the magnification is 20, and in normal vision, magnification is 13.5. So least distance of distinct vision की adjustment में मैग्नीफाइंग पावर ज़्यादा है और नॉर्मल विजन में मैग्नीफाइंग पावर कम है. So this is a very good example, and with this I come to the end of this video, and I'm sure that it is useful to you, all of you. Thank you very much for watching it.